Hello, this is Mr. Bess. Welcome to Chapter 7, homework questions 43 through 48 in Lesson 7.1.4. Question 43. Felipe set his hinge mirror so that its angle was 36 degrees, and the core region was isosceles, as shown below. How many sides did his resulting polygon have? Show how you know. So if you can picture creating 36-degree angles all the way around, remember, a full rotation is 360 degrees. So if we take the 360 degrees and we break them up into how many triangles or angles are of 36, that will give us 10 different triangles. So therefore, how many sides did this resulting polygon have? So each one of these, 1, 2, 3, all the way around, means that you would have 10 sides to that polygon. What is another name for this polygon? If you don't know what another name for this polygon is, maybe you know up to 8 or 9. It will be a regular one in terms of all of the angles or the triangles that are congruent. All the side lengths are the same. This would be called a regular decagon. Question 44. In problem 41, you learned that the diagonals of a rhombus are perpendicular bisectors. If ABCD is a rhombus with side lengths 15 millimeters, and if BD is 24 millimeters, then find the length of the other diagonal, AC. Draw a diagram and show all the work. So the first thing we need to do is set this up and start labeling things so we know what it is that we're looking at. Alright, given the information, I went ahead and set it up. We got rhombus ABCD with side lengths 15 millimeters on each side. BD is the diagonal of one part of the rhombus, which is 24. But the other thing is making sure that you remember that the diagonals of the rhombus are perpendicular bisectors. That tells us two things. They're perpendicular, so I put in the right angle here. But they're bisectors, which means that this side length here is equal to this one. It bisects it into two congruent parts. Same thing over here. These two are also congruent. So if you look at the information we have, then if BD is 24, then that means this side length is 12 and this side length is also 12. So we have a right triangle. We know that the leg of the right triangle is 12 and the hypotenuse is 15, which means we can find this other length right here. And so we'll do 12 squared plus, I'll call that x. X squared is equal to 15 squared. So that's 144 plus x squared is equal to 225. If you then subtract that, you will get 81. So the other side length will be 9 millimeters. And since it's a bisector, it means the other one, is 9 millimeters. And so it's asking us to find the length of the other diagonal AC. So that entire distance of AC then is going to be 18. So AC is equal to 18 millimeters. Question 45. Joanne claims that the point 2, 4 is the midpoint of the segment connecting the points -3, 5 and 7, 3. Is she correct? So we could look at this maybe a couple different ways in terms of graphing it. If you do know the midpoint between 2 points is the sum of them divided by 2 or the average, then you could just figure out the midpoint. So we would say that we know the midpoint will be -3 plus 7 divided by 2, or 5 plus 3 for the y value divided by 2, and so therefore the midpoint would be 4 divided by 2, which is 2, and 8 divided by 2 is 4. And so that, if you know the midpoint formula, then you can prove it that she is correct that way. If you're not aware of that, then what you would probably have to do is show that the distance between the point 2, 4 and -3, 5 would be the same distance between the point 2, 4 and the point 7, 3. So if you show those distances are the same, that will show that at least the lengths are the same, but then you would also have to show that all three of these points, 2, 4, 1, 2, 1, 2, 3, 4, and do it on graph paper, but 2, 4, -3, 5, and 7, 3, somewhere in there, all lie on the same line also, which you could do by showing the slopes or whatever for each of those. being able to draw a line through those. So that's kind of the second way that you could go about that if you weren't sure of the midpoint formula. All right, on question 46, for each pair of triangles below, determine whether or not the triangles are similar. If they are, show the reasoning in the flow chart. If not, explain why. So I went ahead and just to make it a little bit easier and a little bit cleaner, went ahead and put the answers on A and C. So you'll notice that on part A, we have a 42-degree angle. Angle C matches up with a 42-degree angle on angle Y. If you use your triangle angle sum theorem, you'll know that Z is 36 degrees, and you'll also find out that B is 102 degrees. So you find out that angle A is congruent to angle Z. And by that, we have the angle-angle similarity that we can prove that the two triangles are congruent. So for the answer key that they had, they said angle BAC, which would be the angle A that I just showed you. So BAC is equal to the angle XZY. So that'd be XZY. Now I do have a little problem with their notation. Since they're saying they're equal to, there should be the measure right here. So it's the measure of the angle that's equal to each of those. And then the next part they said ACB. So ACB, which is the 42, and the ZYX. ZYX is also the 42. Once again, these should say the measure of those angles are equal. And so we know that triangle ABC matches up with Z, X, and Y. And remember, angle A should be the same as angle Z. All right, angle B should be the same as angle X. They should go in order when you're writing those down to say that they are similar. And also don't forget to include your reason for the similarity, which is angle-angle similarity. All right, on part B, we have two triangles, 6, 6, and 10, and then 3, 5, and 7. We also have an angle that is congruent. So if we look at B, we could look at, since we have all three sides, we can use the side similarity and see if the ratios are the same. So I'm going to go, well, you can maybe tell pretty quickly since these are, we have 6 and a 6 here. This one's a 3 and a 5. Those ratios are not going to be the same. So I can go 5 over 6 is supposed to be equal to 3 over 6, and then would be equal to 7 over 10. But none of that works out, so they're not equal, so therefore they are not similar because the corresponding sides do not have the same ratio. All right, part C. We have two triangles. They're both right triangles, and we have two side lengths for each of them, but we are missing one, but since they are right triangles, we can figure this out. Also, Pythagorean triples, 3, 4, 5 triangle. And this one over here would be a 6, 8, 10 triangle. So either use Pythagorean theorem or your triples to know what those side lengths are. Once you determine that, then you can talk about the ratios. Now, in this flow chart, they do instead of using Pythagorean triples, they use the Pythagorean theorem. So either way is fine, but they show that information, so then they can say that, all right, side DE over GU is 4/8, which is reduced to 1/2, and side FD over BG is 5/10, which is equal to 1/2. And then the one that you did have was the FE and the BU, and that was 3/6, which is equal to 1/2. So that proves that triangle FED is similar to triangle BUG using side similarity. Question 47, if triangle ABC is congruent to triangle DEC, which of the statements below must be true and justify your conclusion? More than one statement may be true. So first, before I start jumping into the statements, let's just go ahead and mark some of our information that we know since the triangles are congruent. Angle A would have to correspond to angle D. So once again, these two have to match up in terms of congruency. B and E have to be congruent, so that means angle B, and angle E, and then angle C and angle C have to be the same, and those are vertical angles as well. Since they are congruent, we know sides have to be incongruent, so AB, so this side length right here has to match up with DE, so AB has to be congruent to DE, BC has to be congruent to EC, and AC has to be congruent to DC. So those are all the things that we know. So now let's look at the statements and see what we can find out. Is line segment AC congruent to DC? Well, let's look. AC is right here, which has the 3 markings, and then DC. And so, yes, that is true. So A is a true statement. Is angle B congruent to angle D? That is no. And once again, you can just look at this one has 2 and this one has 1. Or you can use your congruency statement. Is AB parallel to DE? Well, if it's parallel, if AB and DE are parallel, here's our transversal, and since our alternate interior angles are congruent, then that means that the lines are parallel. So yes, we do know that AB, line segment AB and line segment DE are parallel, so that's good. Do we know AD is equal to BE? So do we know that AD, that has 3 markings on each of them, and BE are congruent? And that's a no. We're not sure that those are congruent. It doesn't have anything to say that they are, that this is an isosceles triangle or anything like that, so that would be an assumption, so that one's out. And then it says none of these are true, which is not true because A and C. So it appears that A and C are the ones that are the true statements. Question 48. On graph paper, graph the points A, B, C, and then which point A or C is closer to B? So I went ahead and plotted the points, and if we want to figure out which point is closer, we could potentially just measure and see. By the naked eye looking at it, to me, it looks like C is closer to B, but to make sure, we want to justify our conclusion here, we just want to find the distance between each of these points. And what you can do is you can create right triangles between points. Any 2 points, you can always create a right triangle. So I'm going to do that. Write the measurements that I know, which would be 2, 1, 2, 3, 4, 5, 6. And then on this one, you have 3, and then 1, 2, 3, 4, 5. And so we're just going to have to figure out each of those distances using Pythagorean theorem. I'll start with the first triangle on the left. That would be 2 squared plus 6 squared is equal to the length of AB squared. So that's 4 plus 36. And so that is 40. And so whatever the square root of 40 is approximately would be that length. And then we can do the other one. We will say 3 squared plus 5 squared is equal to BC squared. So 9 plus 25. And that will be 34. And when you take the square root, you get that BC is the square root of 34 in terms of its distance. So since the square root of 34 is going to be smaller than the square root of 40, we know that point B, or sorry, which point A or C? C. So point C is closer to point